Hi friends, welcome to the new video on Micro Manufacturing Technology, Unit 6 of Manufacturing Process 3. So the course objective, as I told in the first lecture also, is to illustrate working principle of micro manufacturing processes. So in this concern, today we will see the next part of this video or this lecture, that is nano manufacturing. The word itself indicates what is meant by nano manufacturing. So manufacturing at a nanoscale is known as nano manufacturing. So you know 1 nanometer is 10 raised to minus 9, that is 1 billionth of a meter. This term nano was first proposed by Eric Drexler in 1970s. Now in this nano manufacturing technology or the process, there are two basic approaches. One is top-down approach and another one is bottom-up approach. Top-down or bottom-up. The top-down approaches is divided into focused beam lithography and nano imprint technology, lithography. Bottom-down is divided into CVD and dip pen lithography. So these are the two approaches. One is top down and bottom up. Now why we have to go for the nanoscale? In this, the materials exhibit unique properties, increase in toughness, eventually high hardness and low thermal coefficient of expansion. These are the properties or these are the advantages of nanoscale. Once again, let us see top down and bottom up approaches. Top down, as I told you, scanning probe lithography, focused beam lithography, nano imprint lithography, and bottom up approach includes CVD, that is chemical vapor deposition, PVD, physical vapor deposition, dip pen nano lithography and self-assembly. Now, what is focused beam lithography? As you show in the you see in the diagram, the gallium here, this gallium primary ion beam hits the sample surface. This is the sample surface and gallium beam hits the sample surface and sputters a small amount of material, which leaves the surface as either secondary ion or neutral atoms. Secondly, the primary beam also produces secondary electrons. These are the secondary electrons. As the primary beam rosters on the sample surface, the signal from the sputtered ions or secondary electrons is collected to form an image. So initially this gallium beam hits the surface and sputters small material which leaves secondary ions, either I or I minus or neutral atoms. Also it produces secondary electrons. Here you can see these are the secondary electrons. Now what happens in this case, the signal from the sputtered ions or secondary electrons, whatever the signals we are getting from the secondary electrons is collected to form the image. So what it is called as focused beam lithography. Next one is nano imprint lithography. As you know, imprint means some what you say is as a impressions. So here you can see that this is the substrate and this is the resist and this is the mold. Now what is happening in this case? It is a lithography technique which is used to make the nanostructure substrates. Now these are the stamps. These are the stamps that are pressed into polymeric material. This is the resist. Resist is of polymeric material, and this is the stamp which is pressed in the polymeric material or resist that was previously deposited on the substrate. So initially there is a substrate. On that substrate a polymeric material called resist is deposited, and on that resist this stamp is pressed. This stamp is pressed. Now after that, when the stamp is filled with the polymer, the stamp is filled with the this is the polymeric material. This is the polymeric material. This stamp is pressed here. So when this stamp is filled with this polymeric material, it is treated by using ultraviolet light through the stamp. Ultraviolet light is passed through the stamp, obtaining the stamp shape. What is the shape of the stamp? That for getting that shape, UV light is passed through the stamp, and whatever the residual layer of resist is left can be removed, and after that a metal layer can be deposited on the sample. When the resist is removed, the nanoscale metal structure is left on the substrate. So this is the final requirement, nanoscale. This is what? Nanoscale metal structure. So you understood very simple process. One is, first of all, there is a substrate. On that substrate, the polymeric material or resist is deposited. On that resist, what is done? The stamp is pressed. So what happens after pressing the stamp? The stamp is filled with the polymer, which is then treated with the UV light to obtain the stamp shape. And after that, whatever the residual layer of resist is left, that can be removed. And after that, when the resist is removed, the nanoscale metal, after that this resist is removed. After, first of all, that residual layer of resist is removed, and then afterwards this resist is removed, and this the nanoscale structure we are obtaining after completion. So this is known as nano imprint lithography. This is CVD, that is chemical vapor deposition. You are in front of you, you have a diagram of a quartz tube, and that's the gas inlet, target substrate. This is the target substrate. This one is the target substrate. This is the quartz tube, and this is the gas inlet. So CVD, it is a chemical process. As the name suggests, chemical vapor deposition means it is a chemical process which is used to produce high quality, high performance solid material. The process is often used in the semiconductor industry. So whenever you semiconductor industries to produce the thin films. So this process is used majorly in semiconductor industry to produce thin film. So in typical CVD, the substrate, this is the substrate, as you can see, target substrate, this is the substrate. This substrate is exposed to one or more volatile precursors which react and or decompose on the substrate surface to produce the desired deposit. So this you can see the target substrate and desired deposit is obtained. How it is obtained? It is exposed to one or more volatile precursors that reacts and decompose on the substrate. Frequently volatile byproducts are also produced, which are removed by gas flow through the reaction chamber. So it is a very simple process. One, substrate is exposed to one or more volatile precursors that they react with it and on the substrate to produce the desired deposit. So since it is a chemical process, it is a chemical vapor deposition process. Now what is meant by top-down approach? So top-down approach starts from large piece of material and gradually reducing it to a nanostructure. From a large piece to the smaller one to nanoscale. So starts from large piece of material and reducing it to the nanostructure. It is generally used in the semiconductor industry. This is a very reliable and device complexity. However, it uses energy in large amount and produces more wastages. So more wastages are there in this approach due to the use of large amount of energy. The bottom-up approach, that means it involves building up of structures atom by atom or molecule by molecule. In this, you are starting top down, you are starting from the large piece and gradually reducing it, while in bottom up, you are building up the structures either atom by atom or by molecule, which is more economical, and due to that less wastage. There is a less wastage because you are building atom by atom or molecule by molecule, but here in this case you are starting from large piece to reducing it, which can cause more wastage. And since you are building molecule by molecule, the films and the structures are much easier to produce. We have seen the chemical vapor deposition. Now what is meant by physical vapor deposition? It is a surface coating method in which materials are evaporated by either electron beam, ion beam or plasma. Here in this case, materials are evaporated. Here in that process, chemical process, what we have seen in the chemical process? In this, the vapor or the substrate exposed to one or more volatile precursors, which react and decompose it. Here in this case, what is happening? There is no any chemical reaction involved. In CVD, there is a chemical reaction, but in this case, there is no chemical reaction involved in this method, and it is generally evaporation of materials by either electron, ion beam or plasma. Now this process usually requires a high vacuum environment to allow the vapor to reach the substrate and to reduce the impurity of deposited films. So it is a very simple process one. Here you can see the diagram. These are the vapors, and this is how physical vapor deposition takes place. Evaporation of the material. The next one is the self-assembly. It is the autonomous organization of components into patterns or structures without human intervention. That's why the name is self-assembly. There is no any human intervention in the process of building up of components into patterns or structures. Many biological systems now using self-assembly to assemble various molecules and structures. This manufacturing will benefit from application of self-assembly. So this is how you can see there. This is the self-assembly, autonomous one. There is no any human intervention. Now what are the current applications of the nano manufacturing? In the electronic industry, this is used to improve processing speed, memory capacity, reliability. In the sensing units, the use of nanosensors for medicinal purpose and for making nanoscale computer chips. It is also used in the materials and chemical industry, information storage devices. So these are some of the pictures of the nanosensors, and the potential applications include aviation industry, nanobots, pharmaceuticals and biotechnology. Now they are using this nano manufacturing technology. These are some nano applications. Here you can see the medicine, carbon nanotubes, nanorobots, nanotransistor. So friends, this is just the introduction part of the manufacturing process. So in the coming lecture, I will show you exactly this, how nano manufacturing is going on with the help of some of the videos. So in this, I have just given the introduction regarding nano manufacturing. So what is the introductory part? That is, the manufacturing means manufacturing at the nanoscale, and there are two approaches, top down and bottom up approaches. And in top down and bottom approaches, I have given you some information regarding the processes which takes place in top down and bottom up manufacturing and some of the applications of the nano manufacturing. So friends, today, any doubt about this, please ask me the questions so that we can have a very good interactive session among ourselves. Till then, take good care of your health. Thank you very much.